Welcome to Ask and Learn.
Okay, so for problem number 12, we are asked to find how many different trees exist that are non-isomorphic, unrooted with 4 vertices. So I'm going to just kind of show. So non-isomorphic just means that we are not considering the direction. So for example, if I have a 3 vertice diagram, I would have A, B, C. I could have B, A, C. And then I could have CAB, and I could have multiple different combinations. If it were isomorphic, I would have to consider each one of these to be a different tree. However, because of the fact that it's not isomorphic, all of those would be identified as the same type of tree. So what I want to do first is I want to consider where each of them are connected in one straight line, or they're all connected with each of them having a child, and kind of just going from one to the next to the next to the next. So I do have this one, and I'm not going to worry about the labeling because, like I said, it's considering all the different labeling possibilities. Another one could be something like this. Okay, so the only possibilities we have are these, because if we try to go through and say we're going to look at this particular example here, we're looking at example 1. I could do where this one has 2 and this one has 1, but technically that's the same thing because each of them can connect this way. So they can all technically go in a straight line. So I've looked at possibilities where there's, 1 versus 2 versus 3. So the answer is 2. Now, if I want to consider non-isomorphic rooted, but they're rooted, which means that we have to consider that the order does matter just a little bit. So not in the sense that we're going to go through and consider every possibility for each one, but in the sense that I want to label this one A, B, C, D. A, B, C, D. Now I'm not going to interchange any of the order, but I also want to consider what if I have this as my root and this one has 2. So this would be number 3. And then what else? I also want to consider, what if A has 2 and then one of its children has a child? This would also be considered 4. So the answer is going to be 4. So for all in all, I have it where where the root has 1 child. I have it where the root has also 1 child, but instead of each of the children having, and where the second one has a child, this one, the second one would have 2 children. And then I have it where the root has 2 children, and it could go for either one of the children of A to have a child as well. And then I've also considered it where A has 3. If we consider it, so we can't consider anything.